Hi class, this is the part 3 of the pH, pOH, and buffers in Analytical Chemistry Laboratory. Okay, so here in part 3, we will be dealing with more on about the pKa. pKa method of expressing acid strength. So in the previous videos, you have actually seen is yung pH, yung talagang dinedetermine natin, which is the pH determines whether the solution is acidic or alkaline. I repeat, the pH determines whether the solution is acidic or alkaline. But pKa is actually somehow different, because pKa actually determines whether the solution is a strong acid or a weak acid only. I repeat, pKa determines whether a solution is a strong or acid or a weak acid. So, kasi sa pH, pati yung alkalinity is concerned natin. Here in the pKa, we're only concerned with the acidity of the substance. Either is it a strong acid or a weak acid. And then these are the solution condition and the relative amounts of the acid and base forms. This is yung mga representation po niya, which is yung HA is a weak acid and an A is a conjugate base. And then, please do take note that the lower the pKa value of a substance, the stronger the acid strength. I repeat, the lower the pKa value of a substance or a solution, the stronger the acid strength. So, mas mababa daw po na pKa value, mas mataas yung strength niya. So, they are inversely proportional. I repeat, the lower the pKa value, the stronger the acid strength is. So, basically, kung ang pKa value ko is malapit sa 0, so lower, ibig sabihin, mas acidic or mas strong po yung acidity ng isang substance. They are inversely proportional. And here in pKa, guys, wala pa rin tayo talagang takas. So, medyo nasusukan na tayo ngayon sa computations, but wala pa rin tayong takas dito. We have, guys, a formula here, which is somehow magkaparehas with the pH, which is, in this case lang naman, pKa is equals to negative log of Ka, wherein yung Ka po is the acid dissociation constant. I repeat, Ka is actually the acid dissociation constant. And then, the pH is equals to pKa as well. Okay, so using the formula that was given kanina, yung pKa is equals to negative log of the acid dissociation constant, let's try to check in a given example. So given, find the pKa of hydrochloric acid, given that the Ka for the acid is 1.2 times 10 raised to negative 3. So, ito po yung ating Ka value, yung acid dissociation constant value, 1.2 times 10 raised to negative 3. And since ang pinapakuha po sa inyo, pinapahanap is pKa, use this formula. pKa is equals to negative log of Ka or the acid dissociation constant. And in this case, it is already given kung ano yung Ka natin. Again, that is 1.2 times 10 raised to negative 3. Next thing that you need to do, just substitute the given value, which is pKa is equals to negative log of 1.2 times 10 raised to negative 3. Use your scientific calculator right now to check for the given. And then the answer for that, once you input this in your cycle, is 2.92. pKa of 2.92 is now your final answer here in this equation or question. Sige, try natin siya sa cycle ko para makita nyo yung ginagawa. So again, given 1.2 times 10 raised to negative 3. Ayan po, 1.2 times 10 raised to negative 3. You will have 0.0012. Click nyo po yung log. You will come up with the answer negative 2.92. And since this is negative logarithm, just click negative as again or negate the logarithm. So, you will now have a positive answer of 2.92. So, this is the final answer. Okay, so moving on to buffers. Buffer is an aqueous solution containing substances that prevent major changes in a solution's pH when small amounts of acid or base are added to it. It also maintains a particular pH when added to the solution, and it plays a very important role in many chemical and biochemical systems. So with regards to this information, this third information, inside our bodies kasi, ang katawan natin, hindi dapat masyadong acidic or basic. Kaya nga kung natatandaan, di ba, na normal blood pH, again guys, sige nga, what is the normal blood pH? If you can recall in the previous lectures. Diba? That is 7.35 to 7.45, which is somehow neutral. Or neutral talaga, nasa 7, right? So, if that's the case kasi, our body shouldn't be too acidic or too basic. So, inside our bodies, there are many buffering systems that happens inside of us. So, it is very vital that we know how a buffer actually works. So, the buffer actually maintains a solution in a particular pH. Kumbaga, siya yung parang taga-balance. Na kahit mag-add ka ng sobrang amounts ng strong acids or strong bases, the solution shouldn't have major change in its pH. Yun po talaga yung pinaka-purpose ng ating mga buffers. Next, buffer capacity. Buffer capacity refers to the amount that the buffered solution can handle with only a certain small pH change. So, yun nga, kasi nga, di ba, yung mga buffers natin, dapat kaya niyang i-withstand na maglalagay ka ng strong acids or bases. Somehow, the solution shouldn't have a major change with regards to pH. So, that is the buffer capacity as well. Buffer capacity also refers to the number of moles of a strong acid or a strong base that is needed to change the pH of 1 liter of buffer, 1 pH unit. Greatest buffer capacity is obtained when the conjugate base and acid or a conjugate acid or a base are present in equimolar activities. And this is the formula and how to calculate for the buffer capacity. But we will not actually be dealing with this formula. It's just that for additional information. Okay, so in the slide that you are actually seeing right now, I'll be giving you a brief background behind this. Okay, so are you seeing the different dots? The blue-orange dots, this one, this is light blue, and the orange ones is actually a representation of a hydrochloric acid, which is a strong acid. Wherein the blue ones, the light blue ones, is the hydrogen, which is positively charged. And the orange ones here is the chloride ions, which is negatively charged. Again, guys, I repeat, representation ng mga dots, kung ano ibig sabihin nila. This orange plus blue is hydrochloric acid ions, wherein the light blue ones are the hydrogen ions, which is positively charged. And then the orange ions are chloride, which is negatively charged. Next, the purple ones here, ito po, this purple ones. The purple ones represented by letter A is a weak base. I repeat, the purple ones represented by A is a weak base. And then the dark blue ones, this one, the dark blue ones is actually H2O or water. Dark blue with light blue na parang dalawa. Parang Mickey Mouse itsura. This is the water molecules. Okay guys ha, so para mabilis tayo, again, this is hydrochloric ions, hydrochloric acid ions, wherein the light blue ones are the hydrogen, which is positively charged. The orange ones are the chloride ions, which is negatively charged. The purple ones is represented by your A, which is your weak bases. The dark blue ones with light blue na dalawa, this is water molecules, H2O. Okay, so the explanation behind this slide is that the more that there is a weak base, itong mga violet na ito, the purple ones, and weak acid molecules available, the less of an effect addition of a strong acid or base will have on the pH of a system. So again, if there will be more weak base or a weak acid in the available solution, the less of an effect the addition of a strong acid or base will have on the pH of a system. Then consider the addition of a strong acid such as your hydrochloric acid, with regards to this one, ito po, hydrochloric acid. Initially, the hydrochloric acid donates its proton to the weak base. So, the proton, di ba, is the hydrogen. Itong color blue. Tignan nyo dito, nung naglagay tayo ng hydrochloric acid here, yung hydrogen, which is the proton, yung light blue, dumikit po siya dun sa weak bases natin. Ayan o, diba? Dumikit siya eh. Ayan. Yung mga protons or the hydrogen ions. And then, again, ulitin na natin. Initially, the hydrochloric acid ions donates its proton to the weak base, which is the purple ones, through the reaction shown above. So, ito po yan. Hydrochloric acid ions plus your weak base, which is makakakuha ng ganito, which is your weak acid, plus a chloride ion. Okay? This changes the pH by lowering the ratio of a weak base to weak acid, but as long as there is still a lot of weak base or the purple ones present, the change in pH will be small. Kasi nga po, once ito po, maraming available na color purple na yan, so, onti lang yung magiging magkakaroon ng ka-pair, which is yung ka-pair nga po natin is the weak acid. And therefore, since marami pang available na weak bases, hindi pa masyadong magbabago yung pH ng solution. But, if we keep adding the hydrochloric acid ions, the weak base represented by the purple ones will eventually run out. Kasi add ka ng add eh. So, yung proton or yung hydrogen ion po ng hydrochloric acid, makikipag-pair yan dun sa mga purple natin na weak bases. And if there comes a time na sobrang dami mo na talagang inad na hydrochloric acid, lahat na ng color purple natin, ganito oh, meron na siyang mga pairs, di ba? Nagkaroon na siya ng pair, ayan. Magbabago na siya ngayon. O, di ba kapag yung mga kaibigan natin na meron mga ka-pair na o may mga jowa, minsan nagbabago sila, which is in this case lang naman, in the buffer capacity, it may change na the pH of the solution kasi meron na pong pair yung ating weak bases. Naging weak acid na kasi siya. And then, once the weak base is gone, like lahat ng weak base, lahat ng purple na to, ideally meron na siyang ka-pair. Any additional hydrochloric acid will donate its proton to water. So, ayun. Lahat na ng purple ones meron na siyang ka-pair. So, ang tendency ngayon ng ating hydrochloric acid is yung proton niya, idodonate niya ngayon to dun sa water molecules nyo. And if that's the case, nagka-pair na yung hydrochloric acid tsaka yung water nyo, this will dramatically increase the concentration of the hydrogen atoms from the hydrochloric acid, so the pH drops. Guys, as we all know, the more the hydrogen ion concentration there is, the lower the pH. Therefore, parang ang mangyayari is, magkakaroon na ng direct effect ang ating hydrochloric acid kapag sobrang dami nyo na siyang inad. Kasi nga po, naubos na yung ating mga weak bases. Lahat kasi may ka-pair na eh. So, hindi niya na kayang i-maintain yung pH. Ang hydrochloric acid ngayon, yung hydrogen niya will donate that proton in the water, therefore causing the change in the pH. And since maraming hydrogen ion, bababa ang pH. Kasi as we all know, mas mataas na hydrogen ion concentration, mas madami, mas acidic, or mas mababang pH. Okay? We call this breaking the buffer solution. Yun po yung term na yon. And we call the amount of acid a buffer can absorb before it breaks the buffer capacity for addition of a strong acid. A solution with a more weak base mas maraming color violet na ganyan, as a higher buffer capacity for addition of a strong acid. Kasi nga po, parang pinaka-purpose talaga ng weak base na to here in this representation is siya yung makikipag-pair dun sa hydrogen or proton ng ating strong na acid. What if kinulang na yung ating mga weak bases, hindi niya na kaya makipag-pair, yung hydrogen ngayon na manggagaling kay hydrochloric acid will now pair with the water molecules, therefore increasing the hydrogen ion concentration, decreasing the pH. Similarly, a buffer will break. So, kung baliktad naman yung gagawin natin, similarly, a buffer will break when the amount of a strong base, for example, so kunwari sodium hydroxide yung ilalagay nyo dyan, added is so large it consumes all the weak acid. A solution with more weak acid has a higher buffer capacity for addition of a strong base. And that is the reason for this one. Itong nakikita nyo animations right now. So that is the buffer capacity of a substance. Okay, next, ayan, balik na naman po tayo sa computation. We have now the Henderson-Hasselbalch equation. Pagsasamahin naman na natin ngayon, guys, kasi kanina, pH, dun sa mga previous videos, then meron akong diniscuss, right, na pKa kanina. Here in the Henderson-Hasselbalch equation, ito na yung final. Promise, final na to. Ito na po yung pagsasamahin na natin lahat na yon. So, the Henderson-Hasselbalch equation is actually represented by pH is equals to pKa plus logarithm of a conjugate base over a weak acid. Please do take note that this is a recall question in the board exam. I repeat, the Henderson-Hasselbalch equation is a recall question in the board exam. Hindi naman po ganito actually yung pinaka-ginagawa with regards to Henderson-Hasselbalch equation. In the board exam kasi, we are more focusing on using this equation to check for the pH of blood gases inside our body. Tinetest po kasi natin yun as medtex. But here in analytical chemistry, mas concern natin is the mga chemicals. Okay, yung mga compounds, ions, blah, blah, blah. But in medical technologies na board exam, Henderson-Hasselbalch equation is actually being used to calculate for the pH of blood gases. So please do take note, again, Henderson-Hasselbalch equation is a recall question in the board exam. So dapat pong aralin to maigi. Then, pakikabisado po ng formula of Henderson-Hasselbalch equation. That is pH is equals to pKa plus logarithm of conjugate base over a weak acid. And then, ito po yan. Ito yung ibig niya sabihin. Yung pKa, AHA. Ayan ha. Kabisaduhin po ito. Okay? So, stop mo yung video if you want to. Just so makabisado mo siya. Then, if you already memorized this formula, let's now proceed to computation, sample problem. What is the pH of a buffer solution that is 0.6 molar in acetic acid and 1.5 molar in sodium acetate? The pKa for acetic acid is 4.74. Okay. So, ang hinahanap po dito is the pH of a buffer solution, and these are your givens. So, use the Henderson-Hasselbalch equation for this. First thing that you need to do is to check what are the givens. Given 0.6 molar acetic acid. This is your weak acid. Next, the 1.5 molar sodium acetate is your conjugate base. Kasi po, di ba yung sodium acetate, that is a base, right? At as we all know, acetic acid, andun na po yung term, it is a weak acid. And it was already given, what is the pKa? That is 4.74. Okay, so now let's try to use the Henderson-Hasselbalch equation. Just substitute the given solution. So, di ba? pH po yung hinahanap. pH is equals to 4.74, which is, that is already given, plus logarithm of conjugate base. Again, their conjugate base is 1.5 molar from the sodium acetate. Lagay nyo yan dyan. Divided by 0.6, which is yung weak acid, yun yung HA nyo, from the acetic acid. So, sige. First, parenthesis, 1.5 divided by 1.5 divided by 0.6 is 2.5. Then, ito na yung makukuha nyo. pH is equals to 4.74 plus log of 2.5. Use your scientific calculator. Calculate for the logarithm of 2.5. That is 0.3979. Now, you will now come up with pH is equals to 4.74 plus 0.3979. Add nyo lang yan. pH now is equals to 5.14. So again, guys, question, what is the pH of a buffer solution that is 0.6 molar in acetic acid and 1.5 molar in sodium acetate? And then the pKa for the acetic acid is 4.74. Then, yun. Check nyo kung ano yung mga given nyo para madali natin siyang i-substitute. So, yun na nga, acetic acid. So, therefore, that is your weak acid, which is 0.6 molar. Next is your conjugate base, which is the sodium acetate, 1.5. Then, pKa is already given, 4.74. Then, using the Henderson-Hasselbalch equation, pH is equals to pKa plus logarithm of a conjugate base divided by your weak acid. Substitute. pH is equals to 4.74 plus logarithm of 1.5. Ito po, conjugate base, divided by 0.6 weak acid. Calculate 1.5 divided by 0.6 is 2.5. So you will now come up with pH is equals to 4.74 plus log of 2.5. Next, calculate logarithm of 2.5. You will have 0.3979 plus 4.74. You will now have pH is equals to 5.14. Therefore, 5.14 is now the final answer to this question. So, sige, try ko sa CalQ para makita nyo kung ano talaga yung ginagawa. So, di ba, ang unang ginawa ko dyan, 1.5 divided by 0.6, 2.5. Log ko yan. Logarithm of 2.5 is equals to 0.3979 plus 4.74. Final answer is 5.137 or 5.14. And that is the solution to this question. Okay, next sample problem. What is the pH of a buffer solution that is 0.5 molar in ammonium chloride and 2.0 molar in ammonia? The pKa for ammonium chloride is 11.57. Sige. This is somehow challenging. How do you know what is the weak acid and what is the conjugate base? Kasi ammonium chloride and ammonia, somehow, those are both acids, right? But you can actually try to check what is the weak acid and the conjugate base here based on the pKa. If you can recall, right, the pKa is used to check for the acidity of the substance, right? If it is a strong acid or a weak acid. And therefore, if the given here is ammonium chloride has a pKa, we can conclude that the ammonium chloride now is actually the acid part of the equation. And then the ammonia is the conjugate base. Again, guys, I repeat, this question is somehow confusing since we all know that ammonium chloride or ammonia are both bases. So using the Henderson-Hasselbalch equation, how do you check what is the weak acid? And then just try to recall that the pKa, we actually have a given pKa, wherein pKa for ammonium chloride is 11.57. And as you can recall, the pKa is actually determining if a solution is a weak acid or a strong acid. So therefore, we can conclude na since meron po tayong given na pKa kay ammonium chloride, the ammonium chloride now is the weak acid in this problem. So, yun. Ammonium chloride, 0.5 molar, which is the weak acid. The 2.0 molar of ammonia is your conjugate base. And of course, the pKa is already given, which is 11.57. Use the Henderson-Hasselbalch equation. Just substitute. pH is equals to pKa, 11.57, plus logarithm of 2.0, which is your conjugate base, divided by 0.5, which is your weak acid. Then pH is equals to 2.0 divided by 0.5 is 4. Logarithm of 4, try to check that in your calculator. You will have 0.6201. Just add 11.57 plus 0.6201. You will now have an answer of 12.17. Sige. Sabayan kayo ni ma'am na gumawa nito sa inyong calcu. So again, that is, dito muna tayo, ito sa parenthesis, 2.0 divided by 0.5 is 4. Logarithm of 4 is, ito po, 0.60201. Ayan po. And then, add nyo lang po, 11.57, 12.17 is the final answer in this problem. Next sample problem. Find the pKa of acetic acid if the pH of the buffer solution is 3.69 and the concentrations of the following are given. We have 2.5 acetic acid, 2.5 molar acetic acid, and a 1.5 molar sodium acetate. So yeah. Try to check what is the given. So in this case, guys, you are actually looking for the pKa, okay? You're not looking for the pH because the pH is already given. So the given pH is 3.69, right? What is the weak acid and the conjugate base? So yun na po, acetic acid. So therefore, that is your weak acid, 2.5 molar. And then the 1.5 molar sodium acetate is your conjugate base. Using the given, ito po yung tatlong given nyo, use the Henderson-Hasselbalch equation to calculate for the pKa. Ayan. So basically guys, ang hinahanap po natin is, ito po, itong pKa. Ito yung hinahanap natin. Meron tayong given na pH, meron po tayong given na conjugate base, and a weak acid. So sige, substitute. Solution. 3.69, which is your pH, is equals to pKa plus logarithm of 1.5 divided by 2.5. Unahin nyo yung nasa parenthesis, so that is 3.69 is equals to pKa plus logarithm of 0.6. Using your scientific calculator, calculate for the logarithm of 0.6, that is negative 0.2218 blah 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 blah. Okay? Next step, paano nyo po makukuha itong pKa lang? Rules of math. Ito po, this one can be moved to the other side of the equation so that ito lang po yung mareretain nyo, yung pKa nyo. Again, I repeat, ma'am, paano ko po makukuha yung pKa na lang kasi ito na yung values ko? Use the rules of math. Ito po should be given in the other side of the equation or should be moved to the other side of the equation. And since this is negative, once it reach the other side of the equation, that will become positive. Di ba yun yung rules of math kasi? So 3.69 plus 0.22 is equals to the pKa. Therefore, the final answer for this question is 3.91. Sige, sabayan kayo ulit ni ma'am ng pagsagot. So, yun, ang dami talaga nating computations here, no? Ganun talaga. Yan. So, sige. Again, these are your givens na. Here is the Henderson-Hasselbalch equation. Just substitute the given values. We have yung 3.69, okay. Then, logarithm of 1.5 divided by 2.5. Start with the parenthesis po. So, 1.5 divided by 2.5. You will come up with 0.6. Then, logarithm po niyan, click log. You will have an answer negative 0.22. And then, using the rules of math, para po ma-retain itong pKa only, move this value to the other side of the equation. So, since negative po siya, magiging positive siya ngayon. So, 3.69 plus 0.22. Final answer now is 3.91 for this question. So, yun lang po, no? Always be careful dun sa mga givens natin. I think that is where the problems for you guys will arise, is if you do not know how to properly substitute the values. So, always be careful sa hindi lang dito sa buffer, dun sa pH, sa pKa, sa lahat po with regards to the given, because it will also always based on the given kung anong gagamitin na formula as well as kung ano yung mga isa-substitute nyong values. Yan. And then that's it for this lecture and module. Thank you guys so much for listening. If you have any questions or clarifications, you may also reach out to us. Here are our emails as well as in Canvas.